and welcome everyone to one more lecture of probability and statistics. Today we will start our new topic, normal probability distribution. Normal distribution. This is a continuous probability distribution. Next thing is, this is also called as Gaussian distribution. This have a bell-shaped curve. This is generally a structure or curve of a graph of normal distribution. This is a bell-shaped curve, and this is also called as normal curve because it represents normal probability distribution. Now, normal distribution is a distribution which is denoted by small n x semicolon mu sigma, where mu and sigma are parameters of normal distribution, and mu is mean and sigma is standard deviation, which are already given to us, and this probability equals to 1 by under root 2 pi into sigma into e raised to power minus 1 by 2 sigma square into x minus mu whole square. This is function or expression for probability of a normal distribution. Now we will talk about properties of normal distribution. First, this is a bell-shaped curve, and the curve is symmetric about mean. Second property is, in normal distribution, mean equals to mode equals to median. Mean, mode, median are. Our third property is the area between this curve and above the horizontal line is equals to 1. That means integration minus infinity to infinity f of x dx equals to 1. Fourth property is, as we know, the curve of normal distribution is symmetric about mean. So if this is the mean value, then this area and area of this curve are equal, and they equals to 0.5. Now we have one more variable, that is standard normal variate or standard normal variable. Capital Z equals to small x minus mu by sigma, and mean of Z is 0 and variance of Z equals to 1. Now this, as we know, this x is a normal variable and Z is a standard normal. Now let's say if we have two normal distribution and mu1 equals to mu2, they have same mean but different standard deviations. So they can be plotted as, this is mu1 and as mu1 equals to mu2. So one graph will be this and one graph can be this. So if this is for sigma 1 and this is for sigma 2, so sigma 1 greater than sigma 2, because standard deviation is deviation from mean, and this graph is going more far apart from mean value. And if we have same standard deviations but different mean, so this graphs can be plotted as where the distance between, for this y value, between mean and this point will be same in both of them, but the mean values are different. Now we will try to find out area under the curve. Let's say this is our normal curve and this is mean value mu. So if there is one point x1 and there is one point x2 and we want to find out this area where x lies between x1 to x2, so this will be probability of x1 less than x less than x2 equals to integration x1 to x2. Now our probability function for normal distribution was 1 by under root 2 pi into sigma into e raised to power minus 1 by 2 sigma square into x minus mu square into whole square into dx. Now if we want to write this expression in terms of our standard normal variate, so z will be equal to x minus mu by sigma, z square will be equal to x minus mu whole square by sigma square, and dz will be equal to dx by sigma. That means dx will be sigma times dz. So if we will write this and we take value z1 is for x1 and z2 is for x2, so this will be equal to integration z1 to z2 1 by dx is sigma into dz and dz is dx by sigma, dx by sigma. So here we can write dz 1 by under root 2 pi e raised to power minus 1 by 2 x minus mu square by sigma square will be equal to z square. So if we want to find out area between where x lies between x1 to x2, so this will be equal to integration in terms of standard normal variate, this will be z1 to z2 integration 1 by under root 2 pi e raised to power minus z square by 2 into dz. So this is our formula for area under the curve. between 2 points. Now let's say if we have probability for Z greater than Z1, then and we want to find out probability of, this is let's say C, and we want to find out probability of Z less than Z1. So this is our mean value Z0, and let's say there is some point Z1. Probability for Z greater than Z2 will be this area, and we know area under this whole curve equals to 1. So this area will be equal to 1 minus C. If this area equals to C, so this will be 1 minus C. So probability of Z less than Z1 equals to 1 minus probability of Z greater than Z1. Now we will solve a question on how to find out area when we have given some values. Given a standard normal distribution, we have to find out area under the curve to the right of Z equal to 1.84. So we have to find out probability of Z greater than 1.84. Let's say this is 1.84. So this is right area and this is left area. So we have to find out this area. First of all, let's say this is Z equal to 0, our mean value, and here somewhere is 1.84. Now we have given area for Z less than 1.84, that is 0.9671. We are given with the area, with this area, and we have to find out this area. Now we know the sum of these two areas equals to 1. So this will be equal to 1 minus probability of Z less than 1.84. So this will be equal to 1 minus 0.9671, and that will be equal to 0.0329. So this is area for probability of Z standard normal variate greater than 1.84. Now we have to find out area between Z less than greater than minus 1.97 and less than 0.86. Let's draw a graph. So we have to find out, let's say here is Z equals to 0, here somewhere will be point minus 1.97, 0.86. We have to find out this area. Now we are given with Z less than minus 1.97. This area and probability of Z less than 0.86. This plus this area. So we are given with probability of Z less than minus 1.67 and probability of Z less than 0.86. Now if we have this whole area and this area, and we have to find out this area, so we will minus this whole area from that whole area. So this will be probability of Z less than 0.86 minus probability of Z less than minus 1.97. So this will be equal to 0.8051 minus 0.7807. That will be equal to 11 minus 7, 4. 4 minus 0, 4. 10 minus 8, 2. And 7 minus 7, 0. 0.0244. This is our answer for probability minus 1.97 less than Z less than 0.86. That's all. We will meet in our next lecture.